Researchers will soon send a 7-foot-tall observatory on a mission to discover some of the secrets behind the largest body in the solar system, the Sun. Scientists placed a renewed emphasis on the Sun in recent years since it plays such a large role in everything from determining our planet's climate to knocking out orbiting satellites and even taking down power grids on Earth. After launching into Earth orbit aboard a winged Pegasus rocket, NASA's IRIS spacecraft, short for Interface Region Imaging Spectrograph, will stare at the Sun with a steady eye, concentrated on the region between the Sun's surface and its blazing atmosphere, or corona. The region is called the chromosphere, and it's here that temperatures rise from 6,000 degrees Fahrenheit on the surface to millions of degrees in the glowing corona. Researchers don't know why that change occurs, but are betting IRIS will tell them.
I think that the uniqueness of this mission and why it's important is that the mission is looking at the Sun, our only Sun. We know a lot about the surface of the Sun. Massive temperature changes occur in this region. Why? We don't understand this unique region of the atmosphere of the Sun.
IRIS will show the solar chromosphere in more detail than has ever been observed before. My opinion is that we're bound to see something we didn't expect to see.
The Sun often is thought of as little more than a giant nuclear furnace that sits at the center of the solar system and warms our planet. But its effects on Earth are profound, with its heat-driving weather patterns and CMEs, commonly known as solar flares, emitting blasts of radiation into space that threaten satellites and communications networks.
The Sun affects our weather. The Sun affects us in a lot of different ways.
The IRIS spacecraft will study the Sun in conjunction with other solar-sensing spacecraft, including NASA's Solar Dynamics Observatory, or SDO. The main difference between the IRIS mission is that it looks at a tiny portion of the Sun at a time, not the whole disk.
It almost acts like a microscope for SDO's overall telescope. So it's going to look in closely, and it's going to be looking at that specific region to see how the changes in matter and energy occur in this region.
Scientists designed the instrument to return specific data, but they also expect some unexpected results from time to time, too.
The big surprises will come when we start to see the data, because we know to some extent what we hope to learn, what types of observations will answer those questions, but there's always that element of surprise.
A Pegasus rocket built by Orbital Sciences has been employed to lift the observatory into Earth orbit. The Pegasus, which with its wing and tail sections looks a lot like an airplane, is the only launcher of NASA mission that drops from a converted airliner before igniting its first stage engine. Designed as an inexpensive alternative to launch small missions, Pegasus rockets have recorded dozens of successful launches.
The Pegasus launch system is unusual and unique in that you have a mobile launch pad. Pegasus is dropped from the belly of an L-1011 aircraft at 40,000 feet that's traveling downrange at over 500 miles per hour. Pegasus launch system has the theoretical capability of launching from any point on the surface of the Earth.
Pegasus missions have begun from Cape Canaveral, Florida, Wallops Flight Facility in Virginia, Vandenberg Air Force Base in California, and Kwajalein Atoll in the Pacific Ocean. Because the IRIS spacecraft will fly a path that takes it roughly over each of Earth's poles on each orbit, the mission will launch from Vandenberg. The L-1011 will take off from Vandenberg and release the rocket off the California coast, heading south.
What I'll remember most about the IRIS launch is what I remember from all my missions, and that's the people. I'm blessed with a terrific launch team, the NASA team members, as well as Orbital Science Corporation and Lockheed Martin for both the launch vehicle and spacecraft, all terrifically talented and eager and excited to go launch IRIS.
The biggest surprise will come once the mission is launched and it starts to observe the Sun. We always try to map out what sort of events we're going to be targeting, what sort of observations we will be making of those events to improve our understanding of the solar atmosphere and space weather.
We're always looking for the answers of why the physics of our solar system and our planets work. And everything starts at the root with the sun.